All right, review for the first quiz of chapter 7. So it says find the sum of the measures of the interior angles. So remember, that's that formula, n minus 2 times 180. N minus 2 being n, the number of sides, minus 2. So in this case, hexagon, that is a 6-sided object, a sexagon. All right, so that means we're going to do 6 minus 2, which is 4, times 180, which is 720. So over here, number 2, we're going to do 17 minus 2, which is 15, times 180, which is 2,700. A 24gon, we're going to do 24 minus 2 and get 22 times 180, and that gives me 3960. Find the value of x. Well, first off, we have a 1, 2, 3, 4, 5-sided object. This is a pentagon. So it's going to be 5 minus 2, right? So 5 minus 2 is 3 times 180. That's 540 degrees. So there's 540 degrees total in here, which means each one of these is going to add up. I mean, not each one of these. All of these are going to add up to 540. So just start wherever you want. I'm going to start at 2x. So 2x plus 99 plus 89 plus 3x plus 72 equals 540. All right. So I'm going to join like terms. Notice I have these x's here. Okay. So 3x plus 2x is 5x. All right. And I'm going to add the other number. So that's 260. So these three numbers add up to 260. And that equals 540. Now to get x by itself, we need to get rid of the 260 first. Okay, so that's going to cancel, all right? So that's going to be 0, 6 and 8 is 14, 2 and 2 is 4. So that's 280, and that's for 5 x's. But we only want 1 x, so we're going to divide this by 5. And when we do that, we get 56. All right? Now, it just asked you to find x. If it wanted you to find these other angles, you would just plug in 5x here and here and do 5x times 2 and 5x times 3 to get the other angles. All right, so notice here all of our angles are exterior. All of our angles on the outside. Well, remember the trick is the outside is a circle. 360 degrees outside of the shape. So basically, these 5 numbers, 1, 2, 3, 4, 5, or with variables in them, are going to add up to 360. So again, start wherever you want to. Just for space, I'm going to write in the circle. So 94 plus 56 plus 4.5x plus x plus 1.5x equals 360. So I'm going to combine my x's first. So 4.5 plus 1.5 is 6, plus 1 is 7. So that's 7x. And I'm going to add 94 plus 56. That's 150 equals 360. So now I subtract 150 because I'm trying to get x by itself. And that's 7x equals 210. And if I divide by 7, that's 30. Okay? And actually, I shouldn't have put a dot here because they're not degrees. Those are just values. Again, if I wanted to find the values, I would plug in 30 here, here, and here to find those 3 angles. But it doesn't ask you to do that. But always pay attention to the directions in case it does ask you to find the missing angles. All right, find the measure of each interior angle and each exterior angle of the indicated regular polygon. Okay, so we're going to start off like we did at the beginning. So this is a nonagon, which is 9 sides. So 9 minus 2 is 7 times 180. Okay? So we're going to take 7 times 180, which is 1260. Now remember, that is the sum. That is all the inside angles added up. Now, since it's a regular polygon, each angle is the same. How many angles are there? 9. 9 sides, 9 angles. So to find each individual interior angle, we're going to take 1260 and divide it by 9, which is 140 degrees each. Okay? Now the exterior. The trick of this one, remember, is it's always 360. Okay? So all you're going to do is take 360 divided by the same 9, because there's 9 angles. There's 9 interior angles, 9 exterior angles. And that's going to give you 40. And if you notice, that adds up to 180. And it should, because if you come up here and look, this right here is interior angle. Okay? That is supplementary to this. I'm sorry, did I say interior? If I did, I meant exterior. That is supplementary to this interior angle right here because they form a line. They are a linear pair. So the thing is, these two numbers, on number 6 and 7, should add up to 180. All right, so on number 7, same way. We're going to take 25 minus 2, which is 23, times 180. Let's just bring this up. 23 times 180. I can get my 0 to show up. 4140. Okay, so that's 4140 for the interior angles. All right. Now, if I take that 4140 and divide it by, what was it again? 22? 23. 23. Then I'm going to take that 4140 and divide it by 25. I messed up for some reason. I typed in 23. I meant 25 because it's 25 sides and 25 angles. Okay, so 4140 divided by, remember, this, not this number, but this number right here. Okay, 25. And that gives me 165.6. It's a decimal. That's okay. Now, there's actually 2 ways to get this next number. Since you know it's going to be supplementary 180, you could just do 180 minus this number and get this answer. Or you can just take 360 divided by 25 again, because there's 25 angles, and that's going to be 14.4. But again, remember, if I just took this and subtracted from 180, I would get 14.4. All right, find the value of each variable in the parallelogram. Well, remember, opposite sides are equal to each other if it's a parallelogram. So all I have to say is 17 equals x plus 3. Subtract 3, x equals 14. Then I'm going to say y minus 2 equals 38. Add 2 to both sides. Y equals 40. So there's my 2 answers. X is 14, y is 40. All right. Now, remember, opposite angles are equal. So 2u equals 124. Divide by 2. That's a funky looking u. U equals 62. Okay. Now V. Remember, consecutive angles are supplementary. They add up to 180. So if I said V minus 3 plus 124, here's one angle here, here's one angle here. They are supplementary. Notice, one is obtuse and one is acute. They add up to 180 degrees. So if I simplify, I get V plus 124 minus 3 is 121. And then I'm going to subtract 121 from both sides. And that gives me V equals 59. So the key thing to remember here is opposite angles are equal. Consecutive angles are going to be supplementary. And almost always it's going to be one obtuse and one acute. The only exception would be if it was two 90s. Okay? Otherwise, every other time, 99% of the time, it's going to be one obtuse and one acute. All right, last concept. The diagonals of a parallelogram bisect each other. This is the midpoint on both lines. That means this is equal to this, and this is equal to this. So just like number 8, we're literally going to say 27 equals 3s. Divide by 3, s equals 9. And then we're going to say t plus 5 is equal to 19. We're going to subtract 5 from both sides and get t equals 14. And that's it for that page. All right. It says find the indicated measures in A, B, C, D. All right. So EC, where is EC? Well, EC is this line right here. Okay. It's hard to tell because there's a lot going on. But that means EC is equal to EA. Same thing. So EC and EA are the same thing. So since EA is 9.5, that means EC is also 9.5. All right? ABC. Okay? Well, ABC is this angle here. The entire angle. Okay? Okay, so we gotta kind of bounce around here and kind of piece this together. So if you look over here, this angle right here is 65 degrees, the entire thing. So remember, if this is 65, the entire angle, this is a consecutive angle. So they must be supplementary. So 180 minus 65 is 115 degrees. All right? So just think about it. This whole angle over here is 65. These two must be supplementary. All right? BA. Where's BA? Well, BA is over here. BA is the same as DC, which is 8.5. All right? I'm going to kind of clean this up because there's a lot of writing on here. ACD. Where's ACD? So we go A down to C up to D. Okay? The whole angle is 65, right? So we have to find out what just that part is. Okay? So this is where we got to go back to parallel lines and transversal. So if you look at these two parallel lines and this transversal, 30 degrees right here is an alternate interior angle to right here. So if this part is 30, that makes this part 35 to add up to 65. Okay? BEC, where's that? Oh, well, BEC is here in the middle. Okay? Now, the easy way to do this is think about this triangle right up here. AED. The reason I say that is because we already have two of the three angles. Okay? And we're missing this third angle. Well, remember, the angles in a triangle add up to 180. So if I do 30 plus 37, that's 67 degrees. If I do 180 minus 67, I get 113 degrees. Okay, so this is 113 degrees right here. And this is 113 degrees here because it is their vertical angles. And if I wanted to put it in here, these are both 67 because that's supplementary to 180. All right. And last but not least in this problem, it wants us to find dBA. So dBA. So remember, if this is 37 here, that means this is 37 here, alternate interior angles. We found out that angle B is 115. So if we just do 115 minus 37, we get 78 degrees right here. Okay, so this one you got to do a little bit of legwork, and but after you do it, everything kind of falls down like dominoes. All right, state which theorem you can use to show the quadrilateral is a parallelogram. Well, here they're showing both pairs of opposite sides are equal. So that's the rule. If both pair of opposite sides are congruent, then wow, I don't know what's happening there. Wow, it's not letting me write anymore. Then it is a parallelogram. Okay. And let's see what we have here. Here we have this is equal to this, and this is equal to this. Well, we know that if the diagonals bisect each other, which means they cut each other into two equal halves, two equal parts, it is a parallelogram. If you want to just use that symbol, that's fine too. Either way you want to abbreviate is fine. All right, find the remaining vertex of the parallelogram ABCD. So let's plot these. 1, 5 is right here. 1, 1 is right here. So there's A, there's B, and 2, 2 is right there. Okay, so we have this. Wow, that was horrible. Even for me. And then there. Well, remember, opposite slopes are the same. So if I just look at this slope right here, it's up 1, right 1. So if I come up here and go up 1, right 1, there's the other point, D. And that's going to be at 2, 6. Got my letters wrong, sorry. That's C, this is D. Doesn't really matter. All right, so that would be at 2, 6. But let's go back a little bit. What if I looked at it this way? And some people might. What if it went this way? Okay. And I was looking somewhere down here for a point. Well, if I look at the slope from here to here, it's down 1, 2, 3, right 1. So from B, I went down 1, 2, 3, right 1. Then I would have this shape, which is also a parallelogram. And that would be at 2, negative 2. So you actually can choose which way you go with the shape, and it would be correct. All right, A, negative 4, 0. Right there. B, 2, 2. C, 5, negative 1. D, negative 1, negative 3. And it says, show that this is a quadrilateral is a parallelogram. All right. Well, again, for me, since it's graphed, the easiest thing for me, I believe, is to find the slopes of the lines, because all you have to do is count on the graph. All right. So I'm going to count. Again, this was A here, this was B, this was C, and this is D. So I'm going to find the slope from B to C. So from B, I go down 1, 2, 3, right 1, 2, 3. So this has a slope of negative 1. From A to D, I'm going to go down 1, 2, 3, 1, 2, 3, which is negative 3 over 3, or also negative 1. So the slope is negative 1. So those two match. Now I'm going to go from A to B. So from A, I go up 1, up 2, right 1, 2, 3, 4, 5, 6. That's 2 over 6, or 1/3. And from D to C, I'm going to go up 1, 2, and write 1, 2, 3, 4, 5, 6. 2 over 6, 1 over 3. Both pairs of opposite sides slope is congruent. Okay? So both are parallel. All right. Last page. Ways to prove a quadrilateral is a parallelogram. So show that both pairs of opposite sides are parallel. So we just did that. So the way you're going to do that is find the slopes of all the sides by counting on the graph, or if you just had the numbers and no graph, use the formula y minus y over x minus x. And then what you end up doing is proving that this is parallel to this, and this is parallel to this, because they have the same slopes. Show that both pairs of opposite sides are congruent. Okay? So they're going to find the length of all sides. Right? So the distance formula, remember, is x minus x squared plus y minus y squared. Right? So you're going to prove this. Now remember, if this is on a graph, you could not count the slanted lines, but you could count any horizontal or vertical lines and only have to do two distance formulas. So make your life easier wherever you can. Number 3, show that both pairs of opposite sides are congruent. I'm sorry, both pairs of opposite angles are congruent. Okay, so we're trying to prove this. Okay, and we'll use concepts that we already know. Okay, consecutive angles are supplementary. Meaning they add up to 180 degrees. Opposite angles are congruent. All right. And you might also want to think about if you have parallel lines, you're dealing with something. Alternate interior angles are congruent. Show that one pair of opposite sides are congruent and parallel. So in this case, you're just trying to show that these are parallel and congruent. Or it could be, you could have done these two sides also. It doesn't matter. You're just trying to take two sides, one pair. So you pick a pair. Find the slope and distance, which is basically for number 1 and 2 above. Show the diagonals bisect each other. So this line cuts this line in half, like so. So if you find the midpoint of each diagonal, and prove it's the same. And remember, midpoint is x plus x divided by 2, y plus y divided by 2. You're finding the middle, the average of the two. And then here are some formulas that are important. We already talked about above, but there they are right there. And that's it.